Hello. This short video, we're going to review the concept of a tangent line to a curve. And the reason why this is important is lots of times we might want to get a visual of what a differential equation, quote, looks like. Now, that might not make it sound like it make any sense, but we will make sense of that as the course goes along. What I like to do is give you some of the background review so you can make sense of this. So suppose we start off with the equation, and this is from the calculus where we did implicit differentiation. And let's say we're given this particular equation, and we're told to find the equation of the tangent lines at the very first point I want to put out here would be x is 3, y is 2, and x is -3, y is 2. Now, you can check that these, in fact, satisfy the differential equations. The equation, for example, 3 squared plus 4 times 4 is 9 plus 16 is 25, and this also works. So let's get to it. Now, note that the slope of the tangent line is going to be given by dy dx. Now, we're going to go ahead and use basic calculus to find that, but a lot of times in our applications, you'll have dy dx and you'll have the points, and you want to determine what the tangent line is. So we're going to practice implicit differentiation. So you differentiate both sides with respect to x, just as you were taught. And this works out to be 2x plus 2 times 4 is 8y. But since y is assumed to be a function of x, that's dy dx by the chain rule, and you get a 0 here. So then what we get is we get the following equation. 8y dy dx is equal to minus 2x, or dy dx is equal to minus 2x over 8y for y not 0, which is that's minus 2 over 8. Make sure that's right. So that's going to be minus 2 over 8. That's minus x over 4y, right? Now this will give you the slope. These are the given points. So when we go to do this at x is, have to remember this, I'm struggling a little bit. Okay, x is 3, 2. The slope is going to be minus 3 over, in this case, I have to be careful here, minus 3 over 8. And at -3, 2, the slope will be a positive 3/8. So this first tangent line at this point, we use x minus x naught is m times y minus y naught. So at this first point, and I just screwed this up royally. You didn't see that. We get y minus y naught is equal to m times x minus x naught. I'm going to leave this in unedited. I sometimes will go off in outer space. So we have y minus 2 is equal to minus 3/8 x minus 3. And then this other one here, so that's this line. And let's do the next one. The second equation is going to be y minus y naught, which is still 2, is equal to positive 3/8 x minus a minus 3, which is x plus 3. Now let's go to Desmos and see that with our thing here. So y minus 2 is equal to negative 3 divided by 8 times x minus 3. And we see that gives you a nice tangent line here. And then y minus 2 is equal to positive 3/8 x plus 3. And that gives you this nice tangent line right here. Now, what is of interest, and I'll go ahead and take a screenshot of that because I do think it's interesting. So I'll do this. And this is a little bit bumbling way of doing this, but I want us to have this in the notes. So let's take a look at that. And we'll pop this back in. We can see that our graph of our work is shown right here. Now, in differential equations, what we're going to find is that lots of times, instead of being given the underlying equation, in this in differential equations course, you'll be given this part right here. You'll be given dy dx is equal to minus, in this case, x over 4y. And you'll be given the point, in this case, 3, 2, or minus 3, 2. So you're just going to be given this information here. In the differential equations course, what we're going to do is, given these tangents, we're going to try to construct what the solution is given these tangents. So that's sort of the point of the course. But in order to be able to do that, we have to understand that the slope of the tangent line is given by the derivative, and we plug in the appropriate points. So thanks for watching.